Hello, welcome to class. In this class, we will be doing the proof of the derivative of tan x, sec x, cot x, and cosec x. As we remember, the derivative of tan x is sec square x, derivative of sec x is sec x tan x, derivative of cot x is minus cosec square x, and the derivative of cosec x is minus cosec x cot x. So all of this is what we want to prove in this particular video. So we have that. Let's quickly write out the answer. Derivative of tan x will give us sec square x. Derivative of sec x will give us sec x tan x. Derivative of cot x is minus cosec square x, and lastly derivative of cosec x is minus cosec x cot x. So we'll be starting with the first one, and that's y equals to tan x. Now, as you remember that tan x as a trigonometric function is the same as saying sine over cos. So y is equals to sine x over cos x, right? So from there, we obviously see here that it's the functions are dividing. So when the functions are dividing under differentiation, we use our quotient rule. So automatically, so we need to differentiate with respect to x, differentiate v with respect to x, right? So du dx, the derivative of sine x is cos x, derivative of cos x will give us minus sine x. Now let's write out our quotient rule formula. That is dy over dx will give us v du dx minus u dv dx all over v squared. Now to find our answer, which is dy dx, then we need to write our v first. From the formula, v is cos x, then du dx is cos x as well. So if I put cos x there, I'll have cos square x, because cos x is multiplying cos x. I'll have cos square x minus u. Our u is minus sine, our u is sine x. So, and dv dx, which is here, is minus sine x. So if I put minus sine x, it will be what? Plus, because minus times minus will give us plus. Then it will be sine square x. Then all over v, our v is cos x, and that's cos x square, because it is v square. V is cos x, then when it is v square, it's going to be cos square x. So remember that cos square x plus sine square x is 1 from trigonometry. So if that is 1, we'll have 1 over cos square x. Now remember that sec x is the same as saying 1 over cos under trigonometry. So 1 over cos square x will now be sec square x. So the derivative of tan x is sec square x. Our next one is sec x. So remember as well that we said initially that sec is same thing as saying 1 over cos x. So if this is 1 over cos x, then u is 1, then v is cos x, because numerator will be u, denominator will be what? V, in order to use quotient rule. Then du dx, if we differentiate 1, that's the number, it will give us 0. Then dv dx, if we differentiate cos x, we have minus sine x. Now let's use our formula. Dy dx will give us v du dx minus u dv dx all over v square. Now our v is cos x, we have cos x. Then du dx is 0. So what we are going to have here is 0 minus u is 1. Then dv dx is minus sine x all over v square, that's cos square x. So obviously from here, 0 times cos x will give us 0, minus times minus will give us plus. We are going to have sine x over cos square x. So what we have here, we could simplify it to say that this can be written as sine x over cos x multiplied by 1 over cos x, right? Because if we split this cos square x to the two denominators, we splitted it so that we can have sine over cos. And the purpose is because we know that sine over cos is tan, and then 1 over cos is sec. So we can say this is tan x and this is sec x, which can also be written as sec x tan x. So automatically this here is the same as saying sec x tan x. Our next question is y equals to cot x. We know that y equals to cot x is same as saying 1 over tan x. And as well, we know that tan x itself is sine x over cos x. Then when we now do the reciprocal of this, then automatically, in order to write this will go up, this will come down. So this is same thing as saying we would have cos x over sine x. So we could use cos x over sine x to represent cot x. So our u now will be cos x, our v is sine x. Then we can say du dx will give us minus sine x, then dv dx will give us cos x. So using our formula, the y dx will give us v du dx minus u dv dx over v square. Then our v now, our v is sine x. We have sine x, du dx. The du dx is minus sine x. Then u, our u is cos x. Then dv dx is cos x as well. So all over v square, v is sine x. So merely looking at this, we are going to have minus this multiplied by this. That's minus sine square x, and we are going to have minus cos square x. So we would have minus sine square x minus cos square x all over sine square x. Now, obviously from here, I can also factorize minus outside, because I know by the time I factorize minus, I would have sine square x plus cos square x, and that will give me 1. So I would have minus into sine square x plus cos square x all over sine square x. So from there, we could conclude to say sine square x plus cos square x is 1. That's minus 1 over sine square x. Then remember that 1 over sine is cosec, but 1 over sine square x will be cosec square. So the minus here is still here. So 1 over sine square x will be minus cosec square x. So the derivative of cot x is proved as minus cosec square x. For our last one, we have y equals to cosec x. From here, we remember that y, cosec, is same as saying 1 over sine, right? So we could further ahead to say u is 1, v is sine x. Then du dx is what? 0. dv dx is cos x. Now, using our formula, dy over dx will give us v du dx minus u dv dx all over v square. So our v in this case is sine x, our du dx is 0, minus our u 1, then our dv dx is what? Cos x. Then we are going to have v, our v is sine x, so that will be sine square x because it's v square. So sine x times 0 is 0. What we have left is minus cos x all over sine square x. So we can give this as a final answer. We can break it down to say this can be written as minus cos x over sine x times 1 over sine x, because we just splitted the sine square x to two denominators. So we have cos over sine, then we have 1 over sine. So cos over sine, remember that cos over sine, I said it initially that that's cot. So we are going to have minus cot x, then 1 over sine here will give us cosec. So we are going to have minus cot x cosec x as our answer. So the derivative of cosec x is minus cot x cosec x. So you can write it as minus cosec x cot x. It's still the same thing.